This is a very good simulation to make sure that you are understanding some of the finer points of how changing concentrations and temperatures and volumes, how that affects equilibrium. And it's also good for kind of clearing out maybe some misunderstandings that you got along the way. I just need to explain a few points of it before it makes sense. So ignore the heat for a minute. You will see that later. Right now, what we're basically looking at is this H2CO3. And so those are designated in there with, like, if you look in the liquid part, you can see little red pairs of dots. Those are those ones. And then we're going to be messing with them, and we're going to be messing with the green. So you can see there's green above and below, and I know it would be helpful if it was only above so that you could really see exactly what happened. But remember that CO2 does dissolve in water, so some of it's going to be in the gas above the liquid, but then some of it will be dissolved in. But for the purposes of this, I feel like it's really helpful to just watch the green on the top and see if it increases or decreases. I'll mention that again. There's also blue in there. That's just water, and we aren't going to really mess with the water, but it's just in there to let you know that this equation is balanced. The other thing you need to know is that this reaction is being performed at room temperature, 1 atm, and so this is the K value for that reaction. And this comes into the common misperceptions. So when we talk about changing the equilibrium, and sometimes we just kind of shortcut it in how we say things, we aren't trying to change K when we're changing the concentrations. K is what it is. It's unique to a reaction. It's unique at a certain reaction's temperature and pressure, and that's all. So we aren't changing K, but what we are doing is we are messing around with either the numerator or the denominator of K, and it forces the reaction to respond. So we're basically causing an event that freaks out the reaction, and then it like jumps into overdrive and does something to make the equilibrium reestablish. So I'm going to be able to show you that with the pictures, but also I'll show you that with the K value. And then I know this bottle is sideways, but when you do it that way, you can kind of see the CO2 being on the right-hand side, and you can see this one being on the left-hand side, so you can kind of think about it that way. And so the first thing we're going to do is we're going to increase the CO2. Now that's a product, so that means that if we're looking at the fraction, what we're going to be doing is we're going to be increasing the top part. So to maintain the 30, it means then the reaction will respond by increasing the bottom part. That's how the reaction will respond. So when I set this up and when you see this, first thing you'll see is that all the green is going to get bigger because that's that initial disturbance to the force system. So the green's really lots of green. And then the reaction you will see will start to respond once that's stopped. And you'll see that the reaction to reestablish this K value is going to make more of the red. That's the first thing we're going to see. And so again, this is kind of like a picture to show you right here. This is the first thing we're going on. We're going to freak it out and cause this to happen. You can see it should be there, but it looks like that. And you can see this one should be this number. So basically the reaction is going to use this and turn it into this to fix that ratio. Then the second thing we're going to do is we're going to decrease the CO2. And so we're just going to open the lid of the container and let some of it out. Once you do that, then you're going to have less CO2 in the system, and you'll have a misbalance. You'll have way too much red compared to the amount of CO2, so then red is going to be turned into CO2. So I'll mention again as we get going on it. So let's look at this reaction. We're going to do the first thing. We're going to increase the CO2. So you'll see that's a little carbonation bubbler there. So first thing, we're going to increase it. You'll see the bubbles going into the water, so it's green. We're adding green CO2. And then I'll watch the reds. You see how the reds, there's being more and more and more reds made. That's the system's response to us having added it. And now we've reached equilibrium because now our reds and our greens and blues are going back and forth and back and forth. And then I'm going to make this a little wider so she can watch the numbers going on. And then I'll also show you what happens when we decrease it. So let me show you. Over here on the right-hand side, you can see a K equals 30. And you can see the concentrations this has. It has the 0.068 over the 0.0023. So we are adding CO2. So first thing, you're going to see that top number get big. And then all of a sudden, as it makes more red, you're going to see the bottom number basically oomph up to make it happen. So this time, watch that equation. So keep watching the equation. Keep watching it. There we go. We're throwing in all the CO2. It stopped. And now we're making more H2CO3. And you can see how that's making more of it is bringing that K number down, and we've reached equilibrium. So we did the same thing both times. We increased the CO2 and it caused basically more of the reactant to be made. Now let's do it the other direction. This time we're going to decrease the CO2. So we're making the right-hand side less. So when you decrease it, it's basically going to remake more of what you lost. So first, watch the reaction itself. I went the wrong way. And we're going to decrease it just by taking the lid off. There we go. So we've lost some. Put the lid back on. And then now look, the reds are splitting apart and making greens because we are always going to try to remake what we lost until we hit equilibrium. Let me do it again. And watch the K value this time. So again, we are removing CO2, so the top number gets lower. So you can see that top number is going down. Now look, see the bottom number? It's also going down with a little bit top number going up too, but the bottom number is going down until we hit that 30 value. Now you can imagine the reason that we can take advantage of equilibriums and we can kind of make them do what we want them to do is imagine if I did this and I just left the cap off forever. If I left it off forever, it would continuously think that it didn't have enough CO2, which would continuously cause the reaction to make more and more and more CO2. And these are the sort of tricky little things that chemists do in the lab to make reactions happen and kind of force them to do a little bit more than they ever want to do on their own. You mess around with pressure, you mess around with concentrations, and you mess around with temperature. You actually already mess around with temperature too, though, to get equilibrium. You'll find that later on. You naturally do it.